welcome to two projects. In this video, we are going to explain the project Network Intrusion Detection Classification Model based on deep learning. Introduction. The primary goal of this project is to develop a specialized intrusion detection classification model designed for the industrial Internet of Things environment with the specific purpose of enhancing network security. Securing industrial Internet of Things is vital for several crucial reasons. It involves protecting critical infrastructure like power plants and transportation systems to prevent harm and operational disruptions. It also ensures the safety of sensitive data, preserving business confidentiality and uninterrupted operations. Compliance with strict industry regulations is necessary to prevent legal consequences and financial penalties. Moreover, Industrial Internet of Things security plays a pivotal role in safeguarding national interests as compromised systems can pose significant threats to national security. Traditional security methods such as static protection and firewalls face difficulties when dealing with the ever-changing and dynamic threats that are commonly encountered in industrial Internet of Things environments. This is because hackers continuously modify and adapt their tactics to breach security defenses. Consequently, these static security measures find it challenging to effectively protect against these evolving threats, which can lead to vulnerabilities in the network security of industrial Internet of Things systems. To overcome traditional method limitations, the project utilizes deep learning techniques that enhance the analysis of network traffic data for better accuracy and robustness in intrusion detection. These techniques enable the model to learn complex patterns and behaviors, improving its ability to identify and respond to intrusions effectively. And the project's outcomes offer substantial advantages to industrial Internet of Things organizations, and this includes proactive intrusion detection capabilities that identify threats before they cause harm, real-time network traffic monitoring for immediate threat response, and dynamic adaptation to evolving attack techniques ensuring ongoing security. Objective of the project. So, as I mentioned earlier, the primary objective of the project is to create and assess intrusion detection models. These models utilize deep learning techniques such as convolutional neural networks and long short-term memory, and the aim is to enhance network security within the realm of the industrial Internet of Things. By leveraging these advanced techniques, the project seeks to improve the accuracy and robustness of intrusion detection. And to achieve the goal of enhancing network security, the project involves the analysis of diverse datasets. This data is crucial for training and testing the intrusion detection models. By using a wide range of data, these models can learn to detect various types of intrusions effectively. And in addition to deep learning techniques, the project aims to explore ensemble techniques as extension. Ensemble methods involve combining multiple models to enhance overall performance. This exploration is undertaken to further improve the effectiveness of the intrusion detection models. And to make the intrusion detection system accessible and practical for users, the project includes the development of a user-friendly frontend as an extension. This frontend will be created using Flask, a web framework, and will add feature authentication for user security. The purpose is to facilitate user testing and interaction with the intrusion detection system, ensuring ease of use and efficient security management. Requirements needed to execute this project are hardware requirements: operating system of Windows, processor of i5 and above, RAM of 8GB and above, hard disk of 25GB and above. Software requirements needed are Anaconda 3 and Visual Studio Community version. Now we'll discuss the flow of work. The first step is importing required packages. In this step, we will import essential libraries such as NumPy and Pandas for data manipulation, sklearn for data pre-processing, Matplotlib Seaborn for data visualization, and TensorFlow and Keras for deep learning and neural network modeling. The second step is exploring the dataset. The project involves the exploration of various datasets including KDD CUP99, NSL KDD, and UNSW NB15. This exploration phase includes tasks like loading the data, understanding its structure, and conducting initial data analysis to gain insights into the dataset's characteristics. KDD Cup99 is a well-known dataset widely used for intrusion detection research. It was created for the KDD Cup 1999 competition and contains a large volume of network traffic data. This dataset includes a variety of attack types and normal network traffic, making it a valuable resource for training and evaluating intrusion detection models. Whereas NSL-KDD is an improved version of the original KDD Cup99 dataset. It addresses some of the limitations of the KDD Cup99 dataset, such as redundancy and imbalance between normal and attack instances. NSL-KDD is a more balanced dataset which can lead to improved model performance. And UNSW-NV15, that is University of New South Wales network-based 15 dataset, is designed for network intrusion detection research. It includes both raw network packet data and processed flow data, providing a comprehensive view of network traffic. This dataset is more recent and diverse compared to the older KDD Cup99 and NSL-KDD datasets. The next step is data processing. After data exploration, the project proceeds to data processing. This step involves tasks such as cleaning the data, that is, handling missing values, outliers, transforming it into a suitable format, and preparing it for further analysis and model building. The next step is visualization using Seaborn and Matplotlib. In this step, we employ Seaborn and Matplotlib to create visual charts and graphs, facilitating a better understanding of dataset characteristics. The next step is label encoding using label encoder. In this step, we employ a label encoder to convert categorical labels into numerical values, enabling machine learning models to work with them effectively. The next step is feature selection. In this step, we employ select percentile with mutual info classify feature selection method that identifies and retains the most informative features by calculating their mutual information with the target variable. It helps improve model efficiency and generalization by keeping only the most relevant features. The next step is train and test split. In this step, we segregate the dataset into training and testing subsets. The training subset is used for model learning, while the testing subset evaluates the model's performance on new data. And the next step is training and building the model. So we will develop and evaluate various deep learning models in this project. The first model used is CNN, that is Convolutional Neural Network. CNNs excel at learning patterns and features in data, making them ideal for analyzing network traffic data. They efficiently extract spatial information, which can be valuable for intrusion detection in the project. The next algorithm used is LSTM, that is long short-term memory. LSTMs are designed for sequential data analysis, allowing them to capture complex temporal patterns in network traffic. Their ability to understand sequences makes them crucial for identifying unusual behavior in the project. The next model built is combination of CNN and LSTM. So, by combining CNN and LSTM leverages the spatial and temporal strengths of both models. CNN extracts spatial features from network data, and LSTM analyzes the sequences, providing a comprehensive approach for accurate intrusion detection in industrial Internet of Things security. And in the next step, that is extension phase, a hybrid model was created by combining predictions from multiple models for improved accuracy. Additionally, a user-friendly Flask-based frontend with authentication was developed. So we will utilize the extracted and pre-processed data to train the mentioned deep learning models. These models will learn data patterns and relationships within the data. After the training phase, we will assess their performance on a separate test dataset using metrics like accuracy, precision, recall, and F-score to determine their suitability for real-world application. The next step is Flask framework with SQLite for sign-up and sign-in. In this step, we integrate user registration and login functionalities into the Flask framework. Users can sign up by providing their information, and subsequently they can securely log in using their credentials. This enhances system security and allows for personalized user experiences. So, after signing in, users provide input through the front-end interface. The input data are pre-processed to prepare them for prediction by the trained models. This pre-processing step ensures that user-provided data are in a suitable format for the model. And the pre-processed user input is fed into the trained models for prediction. The best performing model is selected to make predictions based on the input data. And the predicted outcome is displayed through the front-end interface, allowing the user to view the results of the model's predictions or analysis. Now we'll see the comparison graphs of algorithms built using NSL-KDD dataset. So this is the horizontal bar graph comparing accuracies of different algorithms. In this graph, on x-axis I have accuracy score and on y-axis I have algorithm means. So accuracy measures the overall correctness of predictions, showing the percentage of correctly classified instances. And this is precision comparison graph. In this graph, on x-axis I have precision score and on y-axis I have algorithm names. So precision measures the accuracy of positive predictions, indicating how many predicted positives were actually correct. This is recall comparison graph. In this graph, on x-axis I have recall score and on y-axis I have algorithm names. So recall measures the ability to identify all relevant instances, showing how many actual positives were correctly predicted. And this is F-score comparison graph. In this graph, on x-axis I have F-score and on y-axis I have algorithm names. F-score combines precision and recall into a single metric, balancing accuracy and completeness in predictions. And these are the comparison graphs of algorithms built using UNSW-NB15 dataset. These are comparison graphs of algorithms built using KDD Cup 1999 dataset. Execution of the project. To execute this project, first we need to open the code folder which contains the project source code files. To execute this project, first we need to open the code folder which contains the project source code files. So this is NSL-KDD folder in which I have NSL-KDD dataset. This is UNSW-NB dataset in which I have UNSW-NB15 dataset. And this is KDD Cup dataset folder in which I have KDD Cup dataset. This is static folder. This folder consists of files related to CSS, JavaScript and Bootstrap. This is templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc. which represent different pages of the website. This is app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML pages. And these are all model files which contain algorithm information. These files will be loaded into the project code during runtime. These are IPYNB files. This is a Jupyter Notebook file which contains a combination of code, graphs and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for data science. And this is signup.db file. This file is the database file used to store user information. Now copy the path of the code folder from the address bar of the File Explorer. I'm copying it. Open the Anaconda prompt. Use the command cd followed by a space and paste the copied path and hit the enter button. So this command is used to change the current directory to the code folder's path. Now compile the app.py file using the command python space app.py. So I'm typing python space app.py and hit the enter button. So this command will execute the Python script and perform a runtime check for any syntax errors or logical issues. And after running the app.py file, the Flask framework will host the application locally at the default address, localhost and port, unless configured differently. Now copy the local link provided by the framework. I'm copying it and paste it into any web browser. I prefer Chrome. After pasting it, hit the enter button. So the home page of the project has been displayed in the browser. This is the front end built using Flask framework. Here we can see a sign up link. Click on it If we are new users, we have to register first. Fill in all these details and click on register button to sign up. And if we already have an account, we can directly log in by clicking on sign in link here. So as I already have an account, I'm clicking on this link. So here we have to provide our credentials, username and password, and click on login. So it has redirected us to the intrusion detection page. So here we have to provide all these parameters. First we'll understand these parameters. So the first one is protocol type. It identifies the network protocol used in the data such as TCP or UDP. The next one is service. It specifies the network service being accessed or utilized. The next one is SRC bytes. It represents the number of bytes sent from the source. The next one is DST bytes. Represents the number of bytes received at the destination. The next one is logged in. It indicates whether a user is logged into the system. The next one is count. Count refers to the number of connections to the same host. SRV count. It represents the number of connections to the same service. SRV different host rate. It calculates the rate of connections to different hosts from the same service. The next one is DST host count. It counts the number of connections to the same destination host. DST host SRV count. It counts the number of connections to the same destination host and service. The next one is DST host same SRV rate. It calculates the rate of connections to the same service on the destination host. The next one is DST host different SRV rate. It calculates the rate of connections to different services on the destination host. DST host same SRC port rate. It calculates the rate of connections from the same source port to the same destination port on the destination host. The last one is DST host SRV different host rate. It calculates the rate of connections to the same destination host but from different source hosts and services. Now we'll fill in all these parameters. So the protocol type would be 1. Service would be 22. SRC bytes would be minus 0.02. DST bytes would be 0.13. Logged in would be 2.39. Count would be minus 1.52. SRV count would be minus 1.15. SRV different host rate would be minus 0.20. DST host count is minus 3.45. DST host SRV count is minus 1.69. DST host same SRV rate is 0.59. DST host different SRV rate is minus 0.2. DST host same SRC port rate would be minus 1.02 and DST host SRV different host rate would be minus 0.15. After filling in all these parameters, now click on predict button. So now scroll down and here we can see the result in the red color text, that is attack is detected and it is U2R attack. Now click on home link. We will give another set of parameters now. So I have entered another set of parameters and now click on predict button. So here we can see the attack. Attack is detected and it's U2R again. Now again click on home. We'll give another set of parameters now. The protocol type would be 1. Service is 56. SRC bytes is minus 0.02. DST bytes would be minus 0.01. Logged in is minus 0.41. count is minus 1.55. SRV count would be minus 1.18. SRV different host rate would be minus 0.20. DST host count is minus 3.5. DST host SRV count is minus 1.76. DST host same SRV rate is 0.59. DST host different SRV rate is minus 0.28. DST host same SRC port rate is 0.82 and DST host SRV different host rate is 23.5. Now click on predict button. So here we can see the result. There is no attack detected and it is normal. Now again click on home link. We will give another set of parameters. So I have given another set of parameters. Now click on predict button. So here we can see the result. Attack is detected and it is DOS attack. So similarly, according to the given parameters, we will get another attacks also as result. The conclusion here is the project achieved impressive results with various deep learning algorithms. Notably, extension model stood out for its exceptional performance, demonstrating the effectiveness of combining multiple algorithms. LSTM exhibited slightly lower performance when compared to other models. And the primary goal of the project, which was to enhance network security within the industrial Internet of Things through deep learning based intrusion detection, was successfully accomplished. The model's strong performance underscores their ability to bolster cybersecurity measures in industrial Internet of Things environments. The project's use of diverse datasets including KDD CUP99, NSL KDD and UNSW NV15 played a pivotal role in enhancing the model's robustness. Training on a variety of datasets allowed the models to adapt to a wide range of network security challenges, making them more versatile and effective in real-world scenarios. And the inclusion of a user-friendly Flask frontend complete with authentication features enhances the practicality of the project. This frontend provides a convenient platform for users to test and interact with the intrusion detection system, ensuring a seamless and secure user experience. The project underscores the effectiveness of advanced deep learning techniques including convolutional neural networks and others. These techniques proved valuable for analyzing network traffic data efficiently and improving intrusion detection accuracy, showcasing their relevance in addressing cybersecurity challenges.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.